Hello everybody and welcome to another edition of Newton's Third Tutoring. Today we're going to be going over the point-slope formula. Now the point-slope formula is a method, or rather an equation, that can be used to create a function for if you have, say, 2 points on a line, or if you have 1 point and the slope of your line. You can create an equation that characterizes that line. Now this is for linear functions only, so if you have a polynomial, like an x squared or an x cubed, you wouldn't use this, but effectively this is a very simple formula that you can use to either get the slope of a line or again to create an equation that characterizes your function. So we're going to be looking at two problems here, but to start we'll look this that you see right here. This is the point slope formula. So y minus y1 equals m times x minus x1. So y and x would characterize your points on the line, as well m here would be your slope. Now the slope, if you were to solve for m in this equation, you'll see on the right is m equals y minus y1 all over x minus x1. And this has also been termed rise over run, by some teachers as well. But effectively, if you have 2 points on a line, you can solve for the slope. So again, m in this equation is the slope of your line. So we'll go ahead and look at problem 1 here to start. So problem 1 states, find the equation of a line passing through points 3, 4, and points 0, minus 3. Write the final equation in slope-intercept form. One thing to note is, whenever you get coordinates for points on a line, it's always listed as x in xy. So 3 would be x, 4 would be y, and 0 would be x, minus 3 would be y. So it's always x, y, and z if you're doing 3D. So solving for this, the problem asks for us to write the final equation in slope-intercept form. Slope-intercept form, and we'll go ahead and show you here. Slope-intercept form pretty much consists of y equals mx plus b. Y and x in this equation are just points on the line, but you don't typically fill those in because you leave those as variables because it allows you to solve for various points on your line, so long as you know what m is, which again is the slope, and b, in this case b is the y-intercept. So this is the point where if x were 0, the line will intersect the y-axis. So again, this is the y-intercept. So the first thing we want to do is we want to solve for the slope. So we want to get what the slope is. So again, going to our equation, the slope m is equal to y minus y1 all over x minus x1. Plugging in our points here, and you can use either variation. We'll go ahead and call 3 and 4 x1 and y1, and 0 minus 3 x2 and y2. So plugging these in, and we can go ahead and call this y2 and x2. Plugging these points in, you'll get minus 3 minus 4 all over 0 minus 3. Further solving for this, you'll get minus 7 all over minus 3, which equals 7/3. And this is your slope right here. So now that we have solved for the slope, we'll need to solve for the y-intercept. Again, this equation is slope-intercept form. So we'll want to solve for b in this case. the way you do this is, now that you've solved for your slope m, you want to take any point on the line and plug it in for y and x, and that'll give you b, which is your y-intercept. So in this case, we'll take 3 and 4 and plug it into the equation. So we'll take, again, we'll take 3.3 and 4, and we'll plug that into our equation, and we'll get 4 is equal to m, which in this case is 7/3, times x, which in this case is 3. Now remember, we're using this point x, y, 3 and 4, and plugging that into our slope-intercept form, and that's plus b. We go ahead and we solve for b in this case. 3's cancel, and you'll get b is equal to, well, why don't we go ahead, so 3's cancel, you get a 7, so we'll do minus 7, and this will yield b equal to minus 3. So minus 7 plus 4 is equal to minus 3, and that is our y-intercept. So now that we've solved for the y-intercept and we've solved for the slope, we can go ahead and plug these values into the slope-intercept form, and that will be the final equation here. So y equals 7/3 times x plus, or rather, not plus, minus 3, because that's our slope-intercept, or our y-intercept rather, and that's our equation here. So you can solve for any point on this line that is generated between these 2 points. But again, this is our final equation. Okay. So moving to problem 2, here we are given the slope, and we want to solve for the equation of the line where, when we have a slope and we have a point, we want to find the equation. So to do this, we already have our slope, so now we need to solve for the y-intercept. So to do that, again, we're going to plug in our point, which is 1/4 minus 2, and this is our x and y. And we want to plug these values into our slope-intercept form. So don't forget this slope-intercept form, very important. We want to plug these values in. So x, or y, equals mx plus b. So y is minus 2 is equal to m, which, remember, m they give us here. M is minus 6. So it'll be minus 6 times x, which is 1/4, plus b. So simplifying this, if we factor here, minus 6 times 1/4, we can factor out, or factor a 2 into the 6, which gives us 3, a 2 into the 4, which gives us 2. And this will yield minus 2 is equal to minus 3/2 plus b. So we want to add 3/2 to each side, and go ahead and solving for this, we'll have to take the minus 2 and convert it to halves, or put it over 2, so it'll be minus 4/2 plus 3/2, and that's equal to positive b here. So solving for this fraction, minus 4/2 plus 3/2, we get minus 1/2 is equal to b. And that's our y-intercept here. So we want to plug that back into our slope-intercept form. Y equals the slope, which, remember, again, they gave us was minus 6. Y equals minus 6x minus 1/2. And that is the equation of the line in slope-intercept form. Well, I hope you enjoyed this video tutorial on the slope-intercept form. Feel free to check us out at www.newtonsthirdtutoring.com for just more videos, more content. If you have any questions or comments, please feel free to email me. This is Thomas Smith, and I'm signing off.